All right, guys. I think it's time to get started. So let's take a look at the first question. Okay. It says there are 7 routes from set A to set B. So to solve this question, guys, I suggest you write down or draw the diagram. So it will be clear for you to solve the question because you don't have the diagram for this question, okay? So get your pen prepared. Let's say we got set A. So let's see, this is A. And also set B. This is too thick. Let me write on the skin. We got set A and set B. And also it tells you that there are 7 roads from set A to set B. So just take note of this 7 ways, okay? So 7 different ways going to lead you from A to B. And then 5 roads from set B to C. This is B, this is C, and you have this arrow. From B to C, you got 5 roads there, okay? It's 5. And then 4 roads from set A to set C, let's say. From A to C, I mean, directly, right? You don't need to go to B firstly. You can just go to C directly. Just skip B, and you have 4 ways to do that. And then let's see what do we have. You have 2 roads from set C to D. So from C to D, we get 2 ways to do that. And now what's next? It says besides, there are also 6 roads from A to D. So this one you can gonna go from A to D directly. And 6 different ways there. Question, how many ways are there from set A to set D in total? So guys, to solve this question, we have to do the classification first. I think someone give me the answer 40, 39. Guys, it's not 40, it's not 39, it's more than that. Yes, I got some correct answers. So basically, type 1, let's say, we're gonna do some classification when you solve such kind of problem. So the first way, I'm gonna say it's the easiest way. If you wanna go from A to D, right? We can just go from A directly to D. Okay, everyone, can you type it to me in the chat box? If you wanna go from A directly to D, how many ways there? How many? Yes, it's gonna be 6, right? It tells you 6 ways from A to D directly. And then let's see, what if we're gonna go from A to C first and then go to D? Let's say I just skip B and I'm gonna go from A to C directly, and then I'm gonna go from C to D. If I do this way, how many different ways there? Is that 6 or is that 8? I'm gonna use 4 plus 2 or 4 times by 2. Guys, it's gonna be times, okay? Gonna be times. Because we have to do something that is like step 1, you're gonna go from A to C. Step 2, you're gonna go from C to D. So if you want to finish this task by doing 2 steps, so you're gonna use the multiplication. And then we're gonna do 4 times by 2, which is 8 different ways, right? 4 times by 2, you got 8. All right, guys, so far so good? From A to C to D, 8 ways. Any questions do you have? I just saw someone raise your hand. Okay, you can unmute yourself now. Tell me your question. Nope.
Why is it times and why isn't it adding?
Can you repeat your question?
So why is it times and not adding?
Why do we use time not adding? Good question. Let's see. So I can do this simple example here. For example, this is A, this is B, this is C. So basically, guys, this is another question, right? This is another question. So let's see, if we're gonna go from A to B, there's 3 ways, and from B to C, 2 ways, okay? So from A to C, how many ways there? If you do the addition, you'll find 3 plus 2, you got 5 ways, but actually you got 6 ways. I'm gonna show you one by one. The first way is that you're gonna go from A to B using this one. And then you have two choices after that, right? So 1 and 2. And I can choose the middle one. I can go from A to B using this one's another way, and I have two choices after that, right? And also if I go from A to B using the last one, and still two choices for me, right, after B. So you'll see what's the total weights there. You're gonna do 1, 2, 3, right? For each of that road, you're gonna go from A to B, you have two more choices. So that's why we use 3 times by 2, we got 6. Does make sense? So in this one, from A to C, you got 4 different ways. And from C to D, you got 2 different ways. So we're gonna do 4 times by 2, we got 8 different ways. Is that clear? Can you type 1 to me if you understand that? The reason why you use the multiplication, not addition. Okay, perfect. And then last one. When we talk about the last one, you're gonna finish this road by 3 steps. We're gonna go from A to B firstly, and then go from B to C, and then from C to D. So since you solve that step by step, right? You're gonna times the different ways by 3 times. So 7 from A to B, times by from B to C 5 ways, from C to D 2 ways. So you times them together, which equals to, I think it's easy to find the answer, right? It's 70. And then to find the final answer of the question, find how many ways there from A to D, you're gonna do 6 plus 8 plus 7, right? So guys, can you tap the answer to me in the chat box? This is the final answer. 84, that's right. The 6 plus 8 plus 70, you got 84 different ways there. Okay, that's it. Guys, are you happy to move on to the next one? Is that clear? Yep. Okay, the next question. Let's see this one. It tells you a 3-digit integer is called a D number if the hundreds digit is divisible by both tens digit and unit digit. For example, 931 is a D number since 9 is divisible by 3 and 1. Question, how many 3-digit D number are there? Okay, guys, I'd like to give you 2 minutes. You can have a try firstly. Okay, 2 minutes, have a try. You could either list all the numbers or try to find the pattern there, doing some calculation and find the answer directly. D number, for example, 111, it's a D number because the hundreds place is 1 and it got both tens and unit digit 1. It's a factor of that, right? Guys, if you got an answer, you can just type it to me. How many 3-digit D numbers there? Only 3? It cannot be only 3. Guys, it's a number between 50 and 100. If you got a number which is between 50 and 100, then that is possible to be correct. You cannot guess it, guys. I just tell you the range, but you cannot guess it. Yes, Eric, you want to say something? I just saw you raise your hand.
What was the answer for exploration 1?
I mean, the previous question, the answer for the previous question is 84.
Thank you.
Mm-hmm.
That's correct.
Does 111 count? Yes, of course it can't, because you know that 1 is divisible by 1, right? Any number is divisible by itself. Okay, guys, I think time is up. Time is up. The correct answer is 67. Does anyone got 67 ways? Let's see, how do we get 67 really fast? Okay. So firstly, you're gonna start with the hundredths place. Let's see, if the hundredths place is 1, as for the tens digit and ones digit, how many choices do you have, guys? How many choices do you have? Only 1, right? Because for number 1, you have only 1 factor, which is just itself. So if the hundredths place is 1, the D number that's gonna meet the requirement is just the 1 of that, which is 111, right? Okay, so what if I change the hundredths place into number 2? Then how many numbers are there gonna meet the requirement? How many? Only 2. I think gonna be 4, guys. Because for number 2, you have how many factors? For number 2, how many factors that you have? You have 2 factors, right? One of factor is 1, another factor is 2. So basically, you can choose either 1 or 2 to fill in these 2 blanks. So we have 2, 2, 2. Or we can have 2, 2, 1, right? Also, you could have that 2, 1, 2. And let's do one more, which is 2, 1, 1. So if you start with 2, if you got 2 in the hundredths place, how many numbers do you have? How many of these numbers do you have? That'll be 4, right? That'll be 4. But are we going to list all of these numbers? You see, there's going to be a lot of numbers to list, right? So you do have a faster way to do it. The way is that if you find this number 2, you see that, okay, for number 2, we have 2 factors, right? 2 factors. And that 2 factors is 1 and 2. So what does that mean? That means if we got 2 in the hundredths place, you still need to fill out these 2 blanks, right? One of that is the tens place, another one is the ones place. As for the tens place, you have 2 choices. It could be either 1 or 2, right? You have 2 choices. And for the unit place, you still got 2 choices. And you just times them that together, you got how many different choices do you have? So 2 times 2, you got 4 different ways. And that 4 different ways is just 2, 2, 2, 1, 1, 2, and 1, 1. Okay, guys, does it make sense? Can you give me 1 if you understand this method using this multiplication way? Yep. Okay, good. And now let's move on to 3. I think if you understand this way, if you start with 3, let's see, guys. For number 3, how many factors do you have? How many factors? 2 factors, right? Since you got 2 factors for 3, that means for this tens digit, you have 2 choices. And for this ones digit, you got 2 choices as well. So you times them together, you got 4 ways. Make sense? So for number 4, if we start from 4, number of factors. Guys, tell me, for number 4, how many factors do you have? 3 factors, right? It's going to be 1, 2, and 4. So you have 3 factors. Since you got 3 factors, if you start with 4, followed by 2 blanks, right? So this number over here, for the tens digit, you got 3 choices. And for the ones digit, you got 3 choices as well. So you times them together, how many different numbers there? What is 3 times by 3, guys? You have 9 different ways to forming the D numbers, right? So 9 ways. Now let's move on to number 5. You will see that number 5 is a prime number. Number 5 is a prime number, so that means you got 2 factors, right? So after 5, 2 choices times by 2 choices. That'll be 4 ways. Yep. Okay, guys, let's move on to 6. So as for number 6, how many factors do we have? How many? Is that 4 factors? 1, 6, 2, and 3, right? So after 6, for the 10th digit, you got 4 choices because you got 4 factors. And also the ones place will be the same, right? So let's see, it will be 16 different ways. Now, guys, we are really close to the final answer. Moving on to 7. And you know that 7 is a prime number, so only 2 factors that you have, right? So 2 times by 2, which gives us 4 ways. And now moving on to 8. 8 blank blank. So guys, tell me, as for 8, how many factors do you have? We have 1 and 8, and we have 2 and 4. So 4 different factors, right? So 4 ways times by 4 ways. There will be 16 different ways there. And then the last one is number 9. So for number 9, how many factors do we have, guys? Since 9 is a square number, so you have 1 and 9, and 3 and 3. But actually 3 is the same. So you have 3 factors, right? So 1, 3, and 9. So 3 times by 3, you got 9 different numbers. Gonna meet the requirement. Okay, guys, last step. We're gonna add all the different ways that we find. So for number 1, there's 1 way. Circle that. Number 2, 4 ways. If you start with 3, you have 4 ways. Start with 5. Start with 4, 9 ways. 5, 4, 6, 16, 7, 4 ways, 8, 16 ways, and 9, 9 ways. Okay, guys, just add all the numbers that you find. And then add them all together. You got 76. Okay? Let's do that. 1 plus 4 plus 4 plus 9 plus 4 plus 16 and also 4 and also 16 and then 9. Okay, I guess that's it. 1, 4, 4, 9, 4, 16, 4, 16, 9. That's it. So guys, do this calculation. Tell me, is that 67? Yep. Very good. So the final answer will be 67 different ways. Okay, guys, does it make sense? Can you type, this time, can you type a good for me if you understand the question? Okay. Very good. Now, guys, let's move on to the next one. Let's see. This is the painting problem. This one will be a little bit complicated. Let's see. It says a square is cut from a sheet of white card and divided into 4, I think going to be identical. Okay, 1 L is missing. Regions as shown. Then each region is painted red, yellow, or blue. So you got 3 colors, red, yellow, blue to choose. More than 1 region may be painted in the same color. That means, Oppo just asked me, why can't you do 101? Because 0 is not a factor of 1. So we cannot have 101 there. Okay. 0 is not a factor of 1. 0 is not a factor of any number. Okay, now let's continue about this question. It says more than 1 region may be painted in the same color. That means it is possible for you to paint all these 1, 2, 3, 4 regions red. Okay, and then how many different painted squares can be made in this way? So guys, be really careful about the mark in the bracket. It tells you that 2 ways of painting are considered the same if you can rotate one to get the other. For example, let's see, guys, if I get red, red, blue, and yellow, this will be same when you do red, red, when you do red, red, yellow, blue. These two will be the same, okay? You cannot count that by 2 times, it's just 1, because when you do this 1 by 180-degree rotation, you got this one. Okay, does it make sense, guys? So you can only count the one that when you do the rotation, you cannot get another one. So firstly, guys, to solve this question, what are we going to do? You still need to do the classification first. Let's see. When we talk about classification means firstly, gonna choose how many colors. Let's say, guys, I can choose only one color, right? If I choose only one color, guys, tell me how many different ways there. If I choose red, I'm gonna paint all the 4 regions red. So that's only one way, right? And I can choose only yellow. I paint all the 4 regions yellow, and also I can paint all the regions blue. So basically, if I choose only one color, there's only 3 different ways for us to paint this card. All blue, all yellow, or all red, okay? That's it. That's about one color. And now let's moving on to 2 colors. If I choose 2 colors. So firstly, guys, you have to help me to choose colors. I'm gonna choose 2 colors out of 3 colors. How many different ways are there for me to choose? I can choose red, yellow. And also I can choose yellow, blue. And also I can choose red, blue, right? If you're gonna choose 2 colors out of 3 different colors, you have 3 different ways to choose that. Okay. But let's see, for one of that, you still need to determine how many colors for each of that we have, right? So for this red, yellow, if you focus on this, if you focus on this red, yellow, and you have 4 regions, right? Let's see how many different choices do we have here. It could be 3 red and 1 yellow, right? And also it could be 2 red and 2 yellow. And last one, we can have 1 red and 3 yellow. Guys, so far so good? Are you still with me? Yep. Okay, guys, question for you. If I choose 3 red and 1 yellow, how many ways that I can arrange them? How many ways there that I can arrange them? Is that only one way? Or 3 ways? What do you think? 1 way or 3 ways? Someone said 3, someone say 1. Actually, guys, there's just 1 way to put that 1 yellow and 3 red. That is because if I had this yellow, red, 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 that's the same as yellow, red, red, red. Because when I do this anti-clockwise rotation, right, by 90 degrees, these 2 will be exactly the same. So I can just count that by 1 time. I cannot have 4 different ways to do that or 3 ways to do that. Okay, it's just the 1 way. Does it make sense? It's just 1 way for that. So let me circle the different ways that we have. This is 1 way. This is 1 way, right? 3 red, 1 yellow will be the same as 1 red and 3 yellow. But what about 2 red and 2 yellow? Is that still 1 way? If we got 2 red, 2 yellow, how many ways there? Yes, guys, 2 ways. It could be either yellow, yellow, red, red. You know that these 2 opposite triangles, the same color, or you can have this adjacent to triangles with the same color. So that will be like this: yellow, yellow, red, red. So 2 choices for you, right? So this one you got 2. And if you count that, there will be 4 ways. Okay, guys, so far so good? Are you with me? Any questions? Make sense? All right. So since that is 4 ways, actually, There's no difference. Can you explain this again? So yeah. You will see that when you have two red, two yellow, it could be either opposite, like this, two yellow, yellow, they're opposite, and red, red, they're opposite. And actually, if you change the place, like if you change that into yellow, yellow, red, red, actually these two are exactly the same. Because when you do the rotation, these two will look like the same. And in the question, it tells you that if you can rotate one to get the other, you can just count that by one time. You can just count that once, okay? But yellow, yellow, these two adjacent, if you put them together, that is not possible to become this one when you do some rotation, right? So that's why we have two ways for two red, two yellow. And in total, you got 4 ways. And since that is just the red, yellow, for yellow, blue, that's the same. That's exactly the same thing, right? You just change the color. The ways that you arrange them will be the same. So guys, let's see. I'm gonna write down the number of ways here. This one's do 4 ways. You don't need to list all of the things because it's the same. And for red, blue, it's also 4 ways. So what does that mean, guys? That means for these 2 colors, if you choose 2 colors, you'll have 3 times by 4, which is 12 different ways to arrange that. Okay? So 1 color, only 3 ways, but 2 colors, you have 12 different ways. And now we're gonna move on to the last type, which is 3 colors. What if we choose all the 3 colors? Okay. If you choose 3 colors, let's see how many ways that we can choose it. So basically, if you choose 3 colors, you have to make sure each of the color you have at least 1 of that, right? You must get 1 red, 1 yellow, and 1 blue, and you have 1 region need to be painted. That means you have 3 choices to choose the number of colors. So we can have 2 red, 1 yellow, 1 blue, or we can have 1 red, 2 yellow, 1 blue, or the last one will be 1 red, 1 yellow, and 2 blue, right? And to solve this, you only need to focus 1 of that. So actually, if you figure out how many ways that you can arrange this type, you times that by 3, you got how many ways that you can have when you arrange 3 different colors, right? So guys, let's take a look at this one. 2 red, 1 yellow, 1 blue. How many ways are there for us to do the arrangement? Think about it. 2 red, 1 yellow, 1 blue. What about we just put that 2 red together? Red and red. We put that 2 red together. So 1 yellow, 1 blue, this will be 1 way. And what if I just swap the place of yellow and blue? I think that will be a new way, right? Let's see. I got red here, and I just changed the position of the blue and yellow. Okay, question for you. Is this 2 will be the same when you do some rotation? Is that possible? No, it's not possible, right? No matter how you do the rotation, you cannot get this red, red, blue, yellow into this red, red, yellow, blue. It's not the same. So at least you got 2 different ways to arrange that, right? So, and that is the way you put 2 red together. And of course, you could put 2 red not adjacent to each other. So basically the opposite. The red, red, yellow, blue. This will be 1 more way. And question, is that possible to do some rotation about that to get this red, red? Let's see, red, red, blue, yellow. Will this 2 be the same? Will this 2 be the same when you do the rotation? Yes, of course, right? When you do 180-degree rotation, you'll find that yellow will move on to right and the blue will move on to left. So this 2 basically is the same. You just count that by 1 time, right? So guys, I'm gonna erase this because these 2 are the same. So what does that mean, guys? Let's do some conclusion. So for this 2 red, 1 yellow, 1 blue, how many different ways that you can arrange them in total? 2 red, 1 yellow, 1 blue. How many ways there? 3 ways, right? This is number 1, number 2, number 3. So you have 3 different ways to do that. Since this one is 3 ways, this will be 3 as well. And this will be 3 because this all the same. 3 ways. Okay, guys, help me to count it. How many different ways are there in total? Because we just finished all the different classification, right? So 3 by 3 got 9 ways. Everyone just type your answer to me in the chat box. What's the final answer to the question? 3 ways, 12 ways, 9 ways. Add them together. Means we have 24 different ways, right? So in total, we have 3 plus 12 plus 9, which is 24 ways. Okay, guys, that's it. That's about this question. What do you think? Is that a hard question for you? What about that? Level 1 to level 5? How you gonna rate the question? Okay. I guess it's a 3, right? 3.5. All right, everyone. It's time to moving on to the next question. And before we go to the next question, I'm gonna review something you learned in the spring term, right? Let's take a look at this one. Warm-up question. It asks you in how many ways that you can arrange the letter. Or means how many ways there for you to rearrange ALL. I think you can just list that directly, right? You have ALL, you have LAL, you have LLA. So basically 3 ways, right? Easy question. But what about the second one? You see the second one, you got 5 letters and P is the same. They're gonna repeat, right? So solve this question, to list all of that, gonna be like waste a lot of time. So actually, guys, for the first one, the method we use, or today I'm gonna introduce you, is that we can treat this 2L as different firstly. Let's call that L1 and L2. If you treat them different, so how many different ways there for you to do the arrangement? There will be, so let's say 3 places, right? Because they are all different when you do L1, L2. So for the first place, you have 3 choices because they are all different. And then for the second place, you got 2 choices because you have already used one of that. And last one, there's no choice, right? So you do 3 times 2 times 1. But that way you will double count. Since you will count that AL1, L2 and AL2, L1 as different, but actually they are exactly the same thing. So you have to get rid of the duplication. So we have to divide it by 2. And how do you get that 2? That 2 is just from L1 and L2. So you're gonna do 2 times by 1. So it's like I do have another question. So to put L1 and L2, how many different ways there? You have this L1, L2 and L2, L1. So basically 2 ways, right? So you do 2 times by 1. And when you do that, 2 will be canceled, 1 and 1 will be canceled. So you get a 3. So that's why we have 3 ways there. Guys, does it make sense? Yep. You understand it? You'll find that if you count it directly, you got 3 ways. And also if you do this kind of calculation, you got 3 ways as well. And then to solve the second question, you got apple. So firstly, we're gonna treat them all as different, right? So we're gonna call that P1 and P2. Since they are all different, so you got 5 letters and put that into 5 different places. So the way that you have will be 5 times 4 times 3 times 2 times 1. And now you're gonna get rid of the duplication, right? So since you got P1 and P2, it's the same. That means you have to get rid of the duplication of P1, P2. So P1, P2, P2, P1 will be two different ways. So you're going to get rid of that 2 times by 1, which gives us this 20 times by 3, which is 60 ways. Any questions do you have, guys? Do you understand this method, this multiplication way? Nope. Yes? Kind of? So guys, basically, why do we use this get rid of duplication? It's like when you do A, P1, P2, LE, and when you do A, P2, P1, LE, these two will be the same. But when you do 5 times 4 times 3 times 2 times by 1, when you do this way, you treat them as different, but actually they are the same. So that's why we have to divide it by 2. Because for P1, P2, and P2, P1, you have two different ways to duplicate that. Okay. So last one, let's see, element. So for element, you have 3 of E's there, E, E, and E. To use this method, guys, we can treat these 3 of E's all as different firstly. So E1, E2, and E3. And that way we'll have 1, 2, 3, 4, 5, 6, 7 different letters, right? If you have 7 different letters, to put them in a row, how many different ways there for you to choose? You have 7 times by 6, times by 5, and then 4, and then 3, and then 2, and then 1. So there will be the total ways for you to list all of these 7 different letters. But that way you will duplicate because you treat the 3 same E as different. So let's figure out, as for E1, E2, E3, how many different ways that we just duplicate that? And here I just list all of that for you. You have E1, E2, E3, and you also have this E1, E3, E2. And also E2, E1, E3, E2, E3, E1. And last two will be E3, E1, E2, E3, E2, E1. So that means, guys, we have to get rid of the duplication, which is 1, 2, 3, 4, 5, 6, right? But how do you get that 6? That 6 coming from how many of E that you have? You have 3 of E, so which is 3 times 2 times by 1. All right, now we can get the answer to the question. How many different ways that we can arrange this? Sorry, this is 1. Okay, so 3 and 3 will be canceled. 2 and 2 will be canceled. 1 and 1 will be canceled. So the final answer to the question will be 7 times by 6, we got 42. 5 times by 4, you got 20. So times them together, you got 840 different ways to arrange that. All right, guys, you have to try to understand this method because if you want to list all of that, it's not possible, right? It's not possible for you to list all the 840 ways one by one. Okay. Does that make sense? Yep. All right. Now, guys, let's take a look at this this question. If you don't understand that, you can take a look at this question. I'm gonna talk about this again. Okay. So it says, but arrange 2 identical pots of roses, 3 identical pots of lilies, and 4 identical pots of sunflowers in a row. How many ways are there to arrange them? So guys, to solve this question, can you tell me how many flowers do we have here in total? How many flowers there? You have 9 flowers in total, right? And you will see that 2 of the flowers the same, right? You have rows, rows, and rows. These 3 are exactly the same. And also you have these 3 identical pots of lilies. So you have L, L, and L. Guys, sorry, it's gonna be 2. I write one more. The 2 roses, 3 lilies, and 4 sunflowers. So you have sunflowers, 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 and sunflowers. Okay. So guys, I got a question for you. If we treat these 9 flowers as all different, how many different ways there for you to list them in a row? If they're all different. If they're all different. How many? If they're all different, you will have 9 times by 8 times by 7 times by 6 times by 5 and then 4 and then 3 and then 2 and then 1. Right? You're gonna count from 9 and yes, it's 9 factorial, right? Times all the way to 1. That will be the total ways if you put 9 different flowers in a row. Because for the first place, you got 9 different choices. For the second place, you got 1 less than that, and until you got 1. But actually, guys, they are not all different, right? These 2 red, they are the same. Means you will double count that. So you count that as rows 1, rows 2, but actually rows 1, rows 2, rows 2, rows 1, it's the same, right? You will duplicate. Now you have to get rid of the duplication. To get rid of duplication for 2 roses, it could be either R1, R2, or R2, R1. So 2 different ways. You just rotate that. You just duplicate that, right? So it's going to be 2 times by 1. That will be the how many ways, how many times you duplicate these 2 roses. And as for the lilies, you got 1, 2, 3. So you put them in a row, how many ways that you duplicate that? You have 3 times 2 times by 1 ways to duplicate that, right? Yes, Nathan?
Why do you start from 9 to go to 1?
Because I have 9 flowers in total. I have 2 flowers, 2 roses, 3 lilies, 4 sunflowers. In total, I got 9 flowers. So I'm gonna start from 9 all the way to 1. So in other words, let's say if we got 1 rose, 1 lily, and 1 sunflowers, how many different ways for you to put them in a line? There'll be 6 ways, right? Because let's say you got 6 places. For the first place, you got 3 choices. It could be either this rose or lily or sunflowers. So you have 3 choices. And since you choose one of that, when you move on to the second place, you have 2 choices left. And when you choose 2 flowers, you have only 1 choice there. So it's 1, and then you're gonna times them together, right? So that's why we do 3, 2, 1, times them together, you got 6 ways. But now here we got 9 different, we got 9 flowers, right? So I just treat them as all different. So I'm gonna do this kind of calculation, starting from 9 and times that all the way to 1. And now I have to get rid of duplication because 2 rows is the same. So I have to get rid of this 2 times by 1, 2 ways. And for lily 1, 2, 3, so that'll be 6 ways, which is 3 times 2 times by 1. And then as for the sunflowers, actually they're all the same, right? So the number of duplication that we have will be 4 times 3 times 2 times by 1. That's it. And now you just do the calculation, you'll find how many different ways there without any duplication, right? So 4 and 4 cancel, 3 and 3 cancel. It's the same. And we know that 3 times by 2, you got 6. So you can get rid of this 6. 2 times by 1 is 2. So you can use 8 divided by 2, you got 4. So basically that equals to 9 times 4 times 7 times 5 in the numerator, right? You have only 1 in the denominator, so you don't need to write down that. 7 times by 8, 63. 4 times by 5, 20. So the answer is going to be 1,260 different ways. Yes, George. George, go ahead. No problem. Okay, that's it, guys. That's the way about duplications. Get rid of duplications. Now, guys, we are moving on to the last question today. If you understand the previous question, you know how to solve this one. Let's see. In this question, it asks you, in how many different ways can the letters in the word winning be arranged? So firstly, guys, we're gonna treat them as all different letters, right? So how many letters there, guys? Can you help me to count it? Is that 7? You have 7 different letters, right? Let's treat them as different firstly. So 7 times by 6, 5, 4, 3, 2, and 1. That will be the total ways we have if they are all different. But actually, they are not all different, right? You got 2n, they are the same. And you got 3n, they are the same, right? N, N, and N. You got 3 n's, they are the same. So you have to get rid of duplication about this n, because you got 3 of that, right? So the duplication, the number of duplication that you have will be 3 times 2 times by 1. That is the duplication of n. And also you will see that for this letter I, you got 2 of that. So you still need to get rid of the duplication in terms of I. Since you have only 2 of that, so the duplication will be 2 times by 1. Okay, so that's it. Now, guys, do this calculation. You'll find how many ways there for you. 3, 2, 1 will be canceled here. 3, 2, 1. And also 2 times by 1 is 2. So 4 divided by 2, you got 2. And now, guys, we have only 1 in the denominator, which is 1. And for the numerator, you're going to have 7 times by 6 times by 5 times by 2. So that means we have 420 different ways to arrange these 7 letters. That's it, guys. That's everything today. Hope you enjoy it and hope you can solve the questions after this session. Any questions? If you got any question, you can unmute yourself. Nope.
Bye.
Bye, guys. I will send
Thank you.
you.
Bye.
Bye.
Bye bye.
Bye.
Thank you. Bye.